Hello everyone and welcome to the second video of the machine learning course for beginners. Before we jump straight into the machine learning, I want to get your hand a little dirty with vectors, array and matrices. These are the building blocks of data manipulation in machine learning. First we will be comfortable with that, then we will jump into the machine learning, right? So we will be using a powerful tool called NumPy to work with them. We also use SciPy for some cases, and now NumPy is not the main focus of this course, but throughout the course we will be using NumPy frequently. So I want to make sure you are comfortable with the most common operation, and this way you can focus on the cool machine learning stuff without getting stuck into the nitty-gritty details, right? Okay, to work with NumPy and throughout the course we will be using Google Colab. So I hope you are familiar with it. If not, you can just type Google Colab in your favorite browser and you will be directly open the Google Colab. You just need to sign in with your Gmail. Okay, so let's first install the libraries. So to install the library in Google Colab, we can use this colon and pip install NumPy. We also need, so let's first install it. And before installing, you make sure you are connected with the compute engine. So as you can see, this is telling the requirement is already satisfied. Now we also need SciPy. So let's install it as well. So for that we will be using pip install SciPy, right? And press the shift enter. To execute the cell we can use this play button also, and we can also use shift enter to execute the cell. As you can see, we are successfully installed the libraries. Now let's import them. First we import the NumPy as NP, and from SciPy we are importing sparse, right? So because we will work with sparse object from the SciPy, that's why I'm importing this only. So let's run this cell by using shift and enter. Okay, so first of all we will see how to create the vectors using the NumPy. So basically vector is just an array with a single dimension. Okay, in order to create a vector we simply create one dimensional array. Array is the collection of elements of the same type in a specific order, right? So these array can be represented in horizontal way or vertical way, and if we create the vector is horizontal we will call row vector, or if we create the vertical vector we call this a column vector. So let's see and how to create these row and column matrix. So first of all we will use this row matrix, and we will simply type np because we have imported this numpy as np.array. I already told you this is nothing but the arrays with single dimension. So this one is the row vector, and if we use this same np.array, and this is the column vector. So in order to print we just simply pass the row underscore vector, right? And in order to print the column vector matrix we simply pass print, and we will type col underscore vector. So let's run it and we can see this is the row vector and this is the column vector. Okay, now let's look at the matrix and what is the matrix and how to create this matrix. Actually to create a matrix we use numpy at two-dimensional array, but numpy actually has also a dedicated data structure called mat object. This is very rare to use, but most of the cases we use two-dimensional array. So let's see how to create it. In order to create, we basically pass np.array, and in a list we will pass two values, first column and the second column, and this is the two-dimensional array. If we print it, we just simply type, we can use this print command as well, and if we simply type this matrix name, this also print the matrix. Let's run it, and you can see this is printing the two-dimensional array. So we can use np.array to create matrix, but there is one more dedicated numpy object called mat, this basically creates also matrix and it also return the matrix. So let's create one variable called matrix object, and for that we will using numpy.mat object from the numpy module and create this matrix. Same value we are using above there, and after setting the value to this variable called matrix object, we let's print it. So after printing you can see it will return the matrix, right? But most of the cases we just use this np.array to create a matrix. This is the very rare case where we will use this. Okay, so now let's look at sparse matrix. A sparse matrix is a type of matrix in which most of the element are zero, right? And sparse matrix store basically only the non-zero values, and rest of all the values of the matrix will be assumed as a zero. And by using this sparse matrix and removing the non-zero values help us to save a lot of computation. So there is a lot of real world scenarios in machine learning where we have a huge amount of data and most of the values element in the data are zero. So basically that kind of scenarios sparse matrix help us. So let's understand this by an example. So for example, imagine a matrix where the column are every movie on a Netflix, basically represent the every movie on Netflix, and the rows represent the every user on the Netflix, right? And the values are how many times user has watched the particular movie, basically placed in a rows, right? And so this matrix would have tons of thousands of columns and millions of rows, right? So most of the user do not watch the most movies, so the vast majority of the element would be zero, right? So this is the example, so where most of the element are zero, and that kind of matrix, if we want to reduce the computation of that, so let's create one sparse matrix and give some zero values and convert it into a sparse matrix and see how it stores only the non-zero values, right? So in order to make the sparse matrix, we also need the scipy library. So that's why I have imported the sparse from the scipy library. So let me show you the cells. So first of all, we have created this one array and stored in the variable called matrix. So this array basically have f- 3 4 zero values and 2 non-zero values, right? So now let's pass this matrix to the sparse and extract the value non-zero values. And in order to extract the non-zero values from this sparse, we only call the CSR matrix from the sparse and passes the matrix to this sparse object, right? And store this matrix as a name of sparse mat, basically represent the matrix. And let's print it and convert the cell. But before that, let me connect it. So I am creating this after some break, so that's why it is disconnected. So now let's run this cell and print the matrix. So actually we need to run this cell import because we have reconnected. So now let's run this cell. So as you can see, it printing the 1 and 3, which are the non-zero values, and this is the index of the values. So first let me explain how this sparse matrix extract the indices of these non-zero values. So basically 1 1 and 2 and 0 is represent the index of the non-zero values, and for example 1 is in the second row and second column, and the 3 is in the third row and first column. And in the first row it's representing the 0, and the second it represents the 0 because the index in numpy has starting from the 0, right? So that's why it's on for the second it's represent 1, and for the 1 it is represent 0. So let's see one more advantage. If we create one large matrix with a lot of non-zero values and extract the non-zero value from these large matrix, so if we use a sparse matrix, it will basically compress it and keep only the non-zero values. So let's create this matrix. I have created this 3 by 5 matrix and store in variable called matlarge, and then I pass this matrix to this sparse dot csr matrix to extract and compress the rows and keep only the non-zero values, and then print it. If we print it, you can see the non-zero value that that is present in this matrix and the non-zero value present in this value has the same index, because this is also present on first row and first column, in second row and second column, and this is present in a third row and first column. So the index shows the same indices of these non-zero values. So this is how we utilize the sparse power to save our a lot of computations, right? Okay, now let's look at the pre-allocating or prefilled NumPy arrays. A NumPy has a function for generating vectors and matrices of any size using the zeros, one, or the value of our choice, right? So let's look at it and how we can generate the values. So this is basically help us in making the code more proficient and using them to make synthetic data to test the algorithm. So if we can see here, we are I am using the numpy.zeros object from the numpy, and I'm passing the shape of 5. So it will create 5 zeros and store in this vector variable, and then we will print it. So let's run the cell and see. So as you can see, it's printing one vector and having the 5 0. Shape basically describe the size of the vector, right? So now let's we can also generate the matrix by using this numpy function. So in order to generate the or creating the matrix, we will use numpy.full object, and we first pass the shape. So shape will basically represent the rows and column. We are generating 3 by 3 matrix and 3 rows and 3 columns, and then the value we want to create the matrix of 1. So it will create this matrix 1 of 3 by 3. Let's run this cell, and if you can see, it's all creating the matrix of 3 by 3, and the values are 1 and 1, right?